Welcome to the APMM Virtual Conference 2021. We'd like to take a minute to highlight one of our excellent conference sponsors, B9 Creations out of Rapid City, South Dakota. A leader in providing highly precise and affordable 3D DLP printers, B9 Creations takes a proactive role to provide solutions to problems model makers face. Let's hear more from B9 in a conversation about the B9 Creations Service Bureau.
Hello, I'm Danny with B9 Creations, a global provider of commercial and custom, high-precision additive manufacturing solutions, whether you need one part or 100,000. We serve high-precision applications from model making to medical, aerospace, manufacturing, and more in nearly 70 countries around the globe. You can see a few of the brands we work with here, from 3M and Procter & Gamble to Medtronic, Pella, and Johnson & Johnson. Here's our global network of strategic partners, dealers, and direct customers around the world. Today we're going to have a conversation with Martin from R5 Training on leveraging our Additive Manufacturing Service Bureau for his innovative accessory for mobile devices. By partnering with B9 Creations on part design and production, he solved in a week what he had spent 1 year on trying to print with other companies and methods. Just talk to me maybe a little bit about your product itself, like how it evolved. Did you try to seek other ways out of manufacturing it? What was that evolution in the design and production before, and then what made you come to us?
Yeah, so I probably have a 24 iterations of the product, and it's gone from so many different materials, from just trying to homegrown this with things you could buy at Lowe's to 3D printing. I have a 3D printer back here. We were trying that thing out. And so the evolution has been, we went through, like I said, 24 different models and things weren't working right, or it created other issues. And so through this whole process, we started trying to find, I tried to find people who were easy to work with. For me, the way I like to do business is I need people who are going to help me. If I'm a transaction, then it's probably not going to work, because we're going into this and we're trying to help people, solve a need, and we want to be that type of business for our customers. And so we look for that. And so I found these guys in South Dakota. They were called Primary, actually, and they were producing the bands. This portion that I had mentioned, this part we call the band. And so they were producing that, went through many different materials from carbon and all kinds of other companies. They really struggled with getting the price point where we needed to be, and they actually recommended B9 for the mushroom portion. They said, hey, these are some good guys, you'll like them. And they knew how I like to do business, and so they sent me over to Luke. Actually, there was another gentleman first, but it was like his last day. He was still really helpful. Send me over there, talked to Luke. We had a couple exchanges, and he really listened to our needs. And then once he plugged us in with Cody, they basically solved in, I think, a week what we had gone back and forth on. I'm trying not to exaggerate it, but it's got to be close to a year. It's at minimum 6 months.
The best way to determine whether to use a service bureau or bring technology in-house is to pair your application and technology goals with your business needs. For instance, how does in-house print speed versus service bureau turnaround time affect the number of part iterations you can run and your overall speed to market? Looking at questions related to this in product development stage, cost, quality, speed, internal resources, technology capabilities, and application requirements can start to paint a picture of where to invest. B9 Creations is a manufacturer of additive technology, but we've opened up a service bureau to help with the exact situation R5 and many other companies face as they begin to scale. A great way to understand if the technology is a good fit is to test capabilities with the service bureau run first. We're here to make sure you're successful in your ultimate production goals. That's why the first step is a consultation and design review. We don't start with the question, how do we manufacture this part? We start with the question, what do you need this part to do? Then we do a feasibility print to ensure we can meet your needs before moving into a larger part run with capacity planning and even work steps you can adopt if you bring the technology in-house. Here you can see our whole additive manufacturing workflow, from software to prints and materials, all the way through post-processing. If you're interested in anything you've heard today and want more information, a product demo, sample or service bureau run, or even a conversation with an additive expert to understand how we can enable your next project, reach out to us at b9c.com/modelmaking.
In today's session, Mike Elschulz, Model Shop Manager at Steelcase, will provide an overview and discussion surrounding the use of various technologies within model making. If you have any questions, Mike, as well as an APMM representative, will be available in the chat, and we encourage you to discuss the concepts and ideas presented with the other attendees. The chat will be open until the end of the hour, and after the workshop has completed, we will have an open Q&A for the remainder of the time. And with that, rock on.
Hello everybody, welcome to the 2021 APMM Conference Virtual. My name is Mike Elschulz. I work for Steelcase for 33 years. I've had experience in engineering, project management, test lab manager, and now the model shop manager. Today we're going to be talking about various technologies, and I'll be sharing with you the use of technologies that we are using, and hopefully we can share with each other ideas during this workshop. Today we're starting into our conference room, which is a little bit older technology, about 20 years old. We're simply using a puck that plugs and plays into your computer, and we simply display it on a display monitor. And we use this frequently for, let's say, one-on-ones with our team. If we have customers, designers, engineers come in, everything seems to be digital. So they all come in with their laptops or tablets. They can plug in and display their projects, and we can have discussions on their projects and what is coming. So we leverage this quite frequently. Not as much as we used to given COVID, but nevertheless, it's still a very useful tool. All right, so let's talk briefly what we're going to be going over today. I will be walking throughout our shop and giving you some real examples of how we're leveraging technology. So hopefully these technologies you'll find will improve your shop efficiency, reduce some costs, save time. But I'm going to show you how we leverage it to manage and track projects, use display dashboards that will do a visual communication with our team and our customer base, which is engineering and design primarily. Different softwares, obviously, you're all most aware of CAD and CAM. We are now using CNC brake press forming, which we actually have Wayne will be doing a session on that. So feel free to jump in, that's a little plug for Wayne. Talk a little bit about 3D printed tools for sheet metal and different uses of the 3D printing. We're going to talk about what we experience with use of ExactFlat, which is a software that we use to develop patterns in our upholstery area, and our 3D scanner is also associated with that, and we'll go into a little bit of detail on that. Okay, what I want to talk about today is our office dashboard. I'm using Tableau here to display a number of metrics that we like to track and or display to help better communicate on a daily basis our workflow and or our employees and who's on vacation, who's not on vacation, etc. So let's start with the equipment. This monitor was a redeployed monitor that we picked up through IT, so that was actually free for us. Then I had to purchase this little device here, which is an Intel stick. It's just a small little computer basically, and it just plugs and plays into the monitor. And then I have my keyboard in my drawer hidden, so I can drive and make changes to the monitor. So it's just wirelessly connected to that Intel stick. So what we're doing here is this is actually driven off of Chrome. So it goes out to a website where I post this dashboard. And so it's just basically refreshing every 15 minutes automatically. At night, it's programmed at 3 a.m. to reboot. So the actual computer itself reboots every day. And this gets refreshed every 15 minutes. So this dashboard does a couple of things for me. First of all, I have an Excel spreadsheet that I'm leveraging for my team to record their vacation plans. So you can see here, it just tracks the next 14 weeks and who's going to be on vacation when. And on this side here is the employee's name and their phone numbers, which is all blacked out for you or X'd out. But if someone was on vacation, working from home, or maybe they had to run out to a plant or a vendor, they can go into this Excel spreadsheet very quickly, click on it, and it'll pop up on the side here saying that Jerry is out to the wood plant, or maybe he's working from home today, or maybe he's out sick or on vacation. So as these individuals go on vacation, it automatically populates in here. So when I come into the office, I can look up here and quickly see who's on vacation, so I don't have to remember who took vacation. Up at the top here is another set of input coming from, again, an Excel spreadsheet, but that Excel spreadsheet is driven from our SAP database, and it gets dumped out every 30 minutes from SAP into an Excel spreadsheet. So throughout the day, as jobs open and close, get assigned, it shows how many are late, hours worked for the week, and if there's any overtime hours that were worked. So this is just some numbers here for quick visual to see just how busy we are and the status of different jobs. And again, that's driven off Excel spreadsheets. So this actual is a Tableau dashboard, and Tableau is just a great software package to create dashboard displays. And we started using it here at Steelcase, 3 or 4 years ago, and it's gained traction. And these dashboards are throughout the company, especially in manufacturing, and they can display whatever you want. You just pull in the data, and it pulls in data from a lot of different sources, including PDFs, believe it or not. So it will actually read a PDF file and bring that data in. It's crazy. But anyways, you can manipulate this in a ton of different ways and export it and output it in a lot of different fashions. So a great little tool, software package. Also, you can leverage this, we can talk later about it, but Excel does the same thing. So this is my old version of my Excel document, and again, it's paper copy, and we used to post it up here. So this tracks billable hours, how many jobs we currently have active, how many new jobs came in, and it's a 10-week running average. And that gets displayed over here once a week. But this is going to be automated onto a dashboard that I can pull up on any computer. Next, I want to show you our monitors that reside out on the main floor on the other side of this wall. And it's powered by 2 old redeployed laptops. Because we're only displaying information onto those screens out there, you don't really need to have a new high-powered computer. So we repurposed some old ones, and all they do is just run the screens. So let's go out there and I'll show you what we display. So here we're outside in the main shop, And this is a main corridor heading out to the parking lot and into the engineering design department. So a lot of traffic comes through here. So this is a great opportunity for us to display a lot of information. So sometimes we'll display work-related, shop-related dashboards, much like I showed you inside. But I wanted to show you some different things that we do display that are just kind of fun. So we do have a Steelcase dashboard that is run by Steelcase, and I just linked to it. Up on top is actually shows you the weather, and this is actually out on Lake Michigan. You can see it's snowing. Kind of looks miserable. So some days we'll grab a live camera feed from Florida on a sunny beach, just to cheer people up a little bit. During March Madness, we like to stream in the games. So on a Thursday or Friday afternoon, we'll throw a game on and just have it running. So when people walk by, they can stop, watch for a couple minutes, and makes them feel good about themselves. During Christmas, we have a sound bar. We'll put a little fire display on and play a little music. I'd like to talk a little bit about generative design. So we use Fusion 360, which I can't speak highly enough of. We love that software product, and they have generative design built into that CAD package. And we had a request to build a generative design table for one of our showrooms. So this is a couple of our mock-ups that we have, and we started off looking at a way of creating a 3D product, but you can see by the size of it, it became pretty complex pretty quick. So these were our first sample pieces, and we ended up going to sheet metal, and it worked fantastic. Generative design takes your design and it optimizes the material that you're asking for and the process, and cuts out, makes it as strong as possible with minimizing the material usage. And so it's kind of cool. It creates some neat products, but I thought I'd share this with you. This is one of our examples that we've kept. I'd like to also share, we have 3D printed tooling that we have actually formed using sheet metal and on our brake presses. We're out here on the main floor at the wood department. I have 4 full-time wood model makers, and what we're displaying here is up on this display. It's just the backlog that the wood team is currently working on, and it's a nice little tutorial that you walk by, you can get a quick shot of where projects are. It really cuts down on some of the questions that the engineers, designers might have. They can simply come here. If they can't find the model maker, they can look up there and kind of see the progress of their jobs. All right, so this particular dashboard gives you a quick tutorial at the very top there where it says team workload. Right now it's looking like we're about a day and a half out on current workload. And then off to the right is our summary. We have 0 unassigned jobs. We have 3 that are not yet started, 4 that are in progress, 7 total jobs. On the right hand side in the status column, we display percentage of complete for each of the current jobs that are in the wood department, and the current target dates. We also have the employee that's assigned to it and a brief description of what that job is, along with the job number. We're at the sheet metal department here. What I'm going to show you is a couple of displays that we leverage here in the sheet metal group. These are both touch screens. We also have a keyboard and a mouse. Personal preference for the team to leverage. In this screen here, they primarily are displaying their workload, and what you're seeing is just an Excel spreadsheet that our team leader at his bench keeps updated, and then the team members here, as they knock off a job, they can come in here and color code it. So green means they're actively working on it, blue is waiting to be put in play, and red is complete. So they just color code this so you can at a quick glance see how many jobs are in play or in process. You can also walk by and look for your job to see the status of it and who might be working on it, who the requester is. In this particular screen, we are leveraging a software package for CAD that is just a viewer, and the team member can bring up the part that they're working on, and in some cases the print that they have might not have all the details on it. So this comes in real handy. They can come here and get a dimension that maybe is missing or is critical to how they're going to form it, that is maybe not on the shown on the drawing. So this piece of software package, and again, it's just a viewer. It's not a full CAD package, and we leverage that just to go in there for information purposes. So it's less costly to our team, but that's all we need at this station. Okay, we're here at the Romer Arm 3D scanner, and I just want to talk about a process that we have developed that has saved us an immense amount of time in our development process of pattern development for upholstery work. So if you imagine a chair where you have to develop 5, 6, 7, 8 different patterns, and you have to constantly tweak them. That was a very manual process, and you'd come up with a pattern similar to this that was a cardboard copy, and every time you had to make a change to it, you'd either trim it, add to it, so you're always working with a physical pattern. What we wanted to do is get into the digital version sooner in the process, so we're leveraging Fusion 360 with an add-on for ExactFlat, and in those cases where we actually have a 3D model, we can actually use that software to create our pattern and send it right to the Gerber, and it's all digitized. There is no physical pattern. But there's a lot of cases where we don't have that, so we actually have to create the first pattern manually. Then what we do is we bring it over here to the scanner, and we'll lay this out on our flat surface, and then simply bring our Romer arm with a probe tip on it and probe around the edges of our pattern, and it gives us a two-dimensional DXF file that now we can send over to the Gerber, which will automatically cut our fabric, and I'll show you that in a second. So now we're over here at the Gerber machine, which is just our fabric cutting machine. So once we have our DXF file, flat pattern, we can send it over to this machine and actually cut out our fabric automatically. Now if we need to make additional changes for the next iteration, we can all do that digitally on our CAD system, and then send it right back to the Gerber and recut it. So we can save on a pattern that used to take, 8-piece pattern used to take an hour to cut out manually, now it takes 60 seconds. So huge savings, and when you're talking about doing a lot of iterations, you can save a lot of time. So on an 8-piece pattern, it used to take us about an hour to manually trace and cut out with a pair of scissors. Now we just send it over to the Gerber, and it literally takes us 60 seconds to cut those 8-piece pattern. And when you're doing an iteration, you can save hours over a course of a week or so. So it's been a huge saving for us in product development, and we've literally cut weeks out of a development schedule because of it. Okay, now we're at our paint drop-off and pickup area in the model shop, where I'm going to ask Carmen to come in here and explain to us how we're tracking our parts that we send out for powder coating.
All right, like Mike said, this is our paid pickup drop-off location. Here in the model shop, we do not use powder coating. We implement that over at the plant. We need to be able to track all the parts that come through the model shop, get sent off to the plant to be powder coated and then brought back in. And while they're over there, we need people to be able to track the process of their parts as they're going through all the different stages over at the powder coating plant. So in order to do that, we are using Microsoft Excel online. It's a very, very nice system. We're able to use different colors to color code for each stage that the parts are going through. We can track how many are going out. We can track what color they are, and we can also send out a link to anyone to view from home, from their computer, from work, so they don't have to come into the shop to just check on their parts. They can see it from wherever they are.
And now on to the Q&A. If you haven't already, head over to the chat, either to your right if you're viewing on a desktop, or below if you're on a smartphone, and join the discussion with the presenter and your fellow model makers. When you are ready, or after the session ends, you can head to the APMM Zoom meetup for further discussion or general information from an APMM representative. This Zoom meetup will be open all day from 9 a.m. to 9 p.m. Eastern Standard Time. For future sessions, head back to the conference schedule page for dates, times, and the appropriate link for each session. And as you discuss, we want to thank the companies and individuals that have supported the APMM and our conference efforts with their donations after we had to postpone our in-person conference last year. Your support means a lot to this organization, and it helped make this conference a reality. Find the names of our amazingly generous conference donors on the screen now. Thanks for coming to this session. We hope you enjoyed it.